Pleasant morning to one and all. I'm Dr. Sumitra from the CSA department, and today's session we are going to handle a back propagation network. The back propagation, short or a back propagation of error, is a fundamental algorithm used to train the neural network. It involves computing the gradient of the loss function with respect to the weight of the networks by propagating the error backward through the networks. This gradient is then used to update the weights and thereby minimizing the discriminancy between the predicted and the actual output during the training. As an overview, I can state that the backpropagation lies at the heart of the training a neural network, enabling them to learn from the labeled data and improve their performance over time. The process begins with the forward propagation of input data through the network to generate the prediction. These predictions are then compared with the ground truth label and the error is computed using a suitable loss function. The backpropagation then operates in two phases. The backward pass, where the error is propagated backward through the network, and weight updates. Whether the gradient of the loss function with respect to the weight is used to adjust the network's parameter, and the loss computation is where the loss function quantifies the discriminancy between the predicted output and the actual label. The common loss function includes mean squared error for the regression task and the cross entropy loss for the classification task. The loss is computed by comparing the network's prediction with the ground trust label, providing a measure of how well the network is performing on the training data. The backward pass, during the backward pass, the error is propagated backward through the network layer by the layer, starting from the output layer and moving towards the input layer. This involves computing the gradient of the loss function with respect to the activation and the weights of each layer using a chain rule of calculus. The gradient are then used to update the weights of the network in the direction that minimizing the loss function. The backpropagation learning algorithm consisting of the following steps where we have the forward propagation, loss computation, backward pass, weight and updates, iterations. First, let us discuss about the forward propagations. The performing a forward propagation to generate the prediction on the trained data. Whereas the loss computation computes a loss between the predicted output and the ground truth label using a chosen loss function. The backward loss propagates the error backward through the network, computing the gradient of the loss function with respect to the activation and weights of each layer. Weight updates use the computed gradients to update the weights of the network using an optimization algorithm such as a gradient descent or its variant. The learning rate parameters controls the size of the weight updates, and the iteration repeats a step 1 to 4 for a multiple epoch until the network convergence or the desired level of performance is achieved. And the type of propagation is all about the standard propagation. In standard propagation, the gradients are computed using a chain rule of calculus, propagating the error backward through the network layer by layer. And the stochastic propagation is all about updating the weights after processing each individual training example, making it more computationally efficient for a large data sets. Batch the propagation. The batch propagation updates a weight after processing a batch of training. An example, striking a balance between the efficiency of stochastic propagation and the stability of a standard propagation. As an advantage, I can state that it's an efficiency towards the back propagation enables the efficient training of neural network by computing a gradients with respect to all weights simultaneously. And we have a flexibility where it allows for the use of various loss function and the activation function, making it applicable to the wide range of tasks. And the scalability is all about the backpropagation scales well into a large datasets and complex network architecture, making it suitable for a real-world application. And the disadvantage is all about vanishing the gradients. Backpropagation can suffer from the vanishing gradient problem, where the gradients become very small in depth network, hindering learning. And overfitting, it is susceptible to overweighting, especially when training on a small data sets or with a complex architecture, requiring a regularization technique to imitate. A local minima backpropagation may convergence to suboptimal local minima of the loss function, affecting the performance of the trained network. As I conclude this, a backpropagation is as a cornerstone algorithm in the field of neural network, driving the training process and enabling the network to learn from data. Despite the challenges such as vanishing the gradient and overfitting, backpropagation has renovarized machine learning and the AI, paving the way for the development of the deep learning model capable of tackling the complex real world problem. As research in optimization algorithm, regularization technique, and the network architecture continues to advance, a backpropagation remains a fundamental tools for building and training the neural network to achieve a remarkable performance across a various domains. I hope you're clear with this concept.